Hello, calculus student. This is the last chapter of the course, chapter 5.7, integral resulting in inverse trig functions. We would introduce, first of all, this rule that involve u and a, which is kind of funny. So if you have a integral that is du a square minus u, I think this is u square. Typo. Okay, so I'll change it in the original notes, but this should be a u square. So if you see things like that, maybe you're thinking of, oh, let's do u substitution. Maybe I can do u substitution and become u to the 1/2, but actually u is the same u. So it's kind of confusing. So what's the best way to do? But then if you do u substitution, it doesn't work, right? So what happened? This is a square. So what happened is, gosh, let me undo it. The pencil will put it here. So then this doesn't, yeah, it should be u square. So whenever you see things like this, if you do u substitution, it will be a square minus like u square equal to u. You expect to have 2x, at the top. So, but this doesn't have, it's just that at the top. So what happened is this would actually become sine inverse u over a. Now, how do they do that? You can look at the book. Okay. 5.7. In the book, they are proving these 3 rules. So the first rule is they prove is you let y equal to sine inverse x over a. And so sine y would be equal to x over a. And then you do implicit derivative, so it becomes a cosine y dy dx is equal to 1 because that's equal to x. So dy is 1 over a cosine y. So dy dx is 1 over a cosine y, but cosine y is square root of 1 minus sine square y, and we know sine y is x over a, so that means we have a 1 over a square root of 1 a square minus x square. So, and then, but x can be generalized to u, so we can say sine inverse u over a would be the answer for a derivative for a integral of 1 over square root of a square minus u square dx. So if this is x, you can just put x over a. Okay, u is to let you do a u substitution later on. So let's go back to our notes. What's the best? And then the other one would be if you have a rational function where the top has nothing, is 1 over, but a square plus u square, then it becomes arctangent. And if you have a top is just du, the denominator is u, square root of u square minus a square, then become arcsecants u over a, 1 over a, arcsecant u over a. So remember, you have to do 1 over a outside. So I think you just need to have this on hand. I would use this, and then the goal is to change your integral into this form. Okay, you can use x if x is u. So let's look at this first one. 1 over 9 plus x squared. What does it look like? It has no roots, so it must be the tangent one, right? So my a would be equal to 3 because 9 is a squared, so square root of it, a is equal to 3. So my x is just u, so I can just write it right away. So that would be 1/3 arctangent. My x is u, so it's x over 3 plus c. So that's the answer. And then the next one would be, I would write, is the 1 minus 9x squared. So it's the a minus u square root, that one. Okay, I'm going to write the rule over here. If I push it up, you might not see it. So I would write du square root of a square minus u square is equal to sine inverse u over a plus c. Okay, so let's see. My a is 1 because 1 a squared minus a something square. Then my u would be with a root of 9x squared. So a is equal to 1. U would equal to 3x because 9x squared, this is u squared. If I square root both sides, it will be 3x. So I get u, I get a. I think I'm fine, right? So I can write it out. Is there 1 over a outside? Oh no, there's no 1 over a. So this is the secant is the one. The sine is the one that where there's no 1 over a. For tangent and secant, you have 1 over a outside. So this would become sine inverse. U is 3x, a is 1, plus c. Just sine inverse 3x plus c. The next one is the x square root of x squared minus 16. So I think it's this one. Just write it out. Just copy that over. So they say if it's du on the top and then u square root of u squared minus a squared, that is equal to 1 over a secant u over a plus c. So it's a matter of finding the correct form. So I think our u is just x, right? U, so x squared to this u squared. So u is equal to x. And what about our a? A is equal to square root of 16 equal to 4. So do we have everything like match? I think so. So this integral would just be 1 over 4 secant arcsecant x over 4 plus c. So if you know how to match them, it should be fine. Example 4 would be a little harder. So it's the tangent one. I'm going to copy it over again. du a squared plus u squared. So that means this form is du should equal to 1 over a. Was it? Is it arctangent x over a? U over a? Yeah. U over a plus c. So let's see. My age. So 25 is equal to a squared. So my a would be 5. My u squared is 16x squared. So my u is 4x. So that exactly match it, right? So that would means my answer would be equal to, so this integral would equal to 1 over 5 arctangent of 4x over 5 plus c. So you see it is not very difficult. There's no calculation per se. It's primarily matching it. So do I have time to actually go over the inverse or the definite integral? Maybe I'll just do one more.